Hi, welcome back to Dr. VASU'S lectures. Now, in continuation of our C language, we are going to see type conversion or data conversion in this video. What is the type conversion? Type conversion is one which is used to convert one data item to another data type. So, one data type is converted to another. Why? Sometimes we have to convert them to other data type. Otherwise, there will be a possibility of errors, right? We'll see what type of errors we get and how to rectify them and how this conversion takes place, right? So this can be from integer to float, or float to integer, or character to integer, or integer to character. This sort of conversion can be there. So this converting one data type values to another data type is called type conversion or typecasting or data conversion. All means same, right? So let us see what is this data conversion or type conversion. Suppose type conversion can be done in two ways. One is implicit, another explicit. Implicit conversion where the system automatically takes the conversion, does the conversion. Here, it is done by the compiler. The role of a programmer is not there in this. Programmer need not intervene, and the compiler itself will take place, will do the job. In the case of explicit conversion, the programmer has to do it. It is the role of the programmer who has to do this job. Let us see how and why. Before proceeding further, if you like these lectures, like, share and comment, and also subscribe to Dr. VASU'S lectures. I have designed all these lectures very easily understandable and easy to remember also and to reproduce, right? So subscribe to the lectures. Next, let us proceed to typecast operator, right? Typecast, that is a conversion. I want to see character to integer, how this takes place. Suppose, so I want to convert character to integer. Where it is required. Suppose I have taken a character, I have the character C1, assigned a letter A, small letter A to C1. Here I want to display this as it is, because it is a character. I will use %C, and C1 is used here. Next, I'm not doing anything, but I want to just, I'm using C1 as it is, but instead of character, I want to display it as integer. Let us see what happens. Another way is, this same C1 I have taken, and I am doing intentionally, I have written within brackets integer. The meaning of it is, this character data type is to be converted to integer type. So this is the way of converting one data element to another data type. So here, because it is an integer, I want to show it as integer, display as integer. Complete the program, compile it, and execute. We get C1 is equal to A, no problem, because C1 is declared as, I want to display it as character, no problem. In the second printf, I have taken C1, which is a character, but I want to display it as an integer. What happened? I haven't done any conversion, right? I have not done it. Programmer has not done anything. So it is showing the value of this ASCII value of this small letter A, that is 97. So here what has done? The compiler is acting. Compiler did the job. How? It is showing this character value in integer form. So that's why, suppose I have converted intentionally, I have converted this character into integer. Let us see what happens. Here also the same thing. So whether you did it or not, the compiler acts accordingly. Compiler automatically converts character into integer without our intervention. Okay. So we need not write this actually. Compiler takes the job. This type of conversion is called implicit conversion because it is automatically done without our intervention. It is called implicit conversion. Let us see the other way. Integer to character. Next. I want to convert integer to character. I have taken n1, an integer, assigned 100 to it. Printf. I want to display n1 as integer, no problem, because it is an integer. Here, I want to display this n1 as character. I am not doing any conversion, without conversion. I am not doing any conversion here, right? Just take an n1 as it is. Next, in this printf, n1, I want to convert it into char, the character type. When you want to convert this into character type, right? And we'll be displaying it as character. Let us see what happens. Compile this and execute. N1 as integer, no problem. N1 as integer, it shows its original value 100, right? Without we did anything, it is showing its value. 100 means its ASCII value of D is 100. So it is showing the small letter D. We haven't done anything here. But here we did something. We intervened and we tried to convert it into character and tried to display. Even after we did this conversion, it is showing the same. So whether you did it or not, the system itself will do the job of converting character into integer or integer to character. That's how this implicit conversion takes place. Clear? Next. This is the what is the advantage of this implicit conversion? Let us see. I have taken an integer A assigned 100, a character B assigned a letter A, capital A, another integer sum. I want to sum these two. You may be wondering, how come we are doing this addition operation on integer and a character? Let us see. My aim is I want to get the ASCII value of this character B. B means, of course, it is capital A. I want to get the ASCII value of this character A, and I want to add this to A, 100. Okay, that is the aim. Let us see what happens. Printf, I want to just print the value of A, integer, no problem. Print B, no problem again. Yes, here is the problem actually. B actually is a character, but I want to display it as integer. Next. Sum, I want to display it as integer again because it is integer. Let us see what happens. When you see compile and execute, we get A is equal to 100, no problem. B is equal to 65. You see, we haven't done anything. The compiler automatically comes into picture and it does this conversion. B is converted to integer and it is showing its the capital A letter ASCII value is 65. So it is showing the ASCII value here. Next, so A plus B, B is automatically converted to number. So 100 plus 65, sum must be 165. That's how we get it. Clear? Here you may be wondering what happened to actually my letter B, the character which we have, the variable B. We have taken B, right? It is a character. What happened to this? Is there any change into this B? Let us see. I want to display this B as a character here. Yes, its value doesn't change, but we are just utilizing its converting it into integer and utilizing it. And without our intervention, the system is doing it. That's why we call it as implicit conversion. So this is the next typecast operator. Let us see one more example. I want to convert integer to float, integer to floating value. I have taken a I1 as integer. Its value is 45. So printf, I want to print the value of I1 as integer. Next, printf I1 value as float. I am not doing anything here without converting. I have taken integer I1 as it is, but I want to display it as float. Let us see what happens. Here, I am converting, right? I1 value, I am converting it to float. How? In front of it, within brackets, just write float. That means this integer value to be converted to float. That is the meaning of it. So, because it is a float, I want to display it as float. Now, in this case, let us see how will be the display, the output. Compile and execute. The I1 as integer, integer here, its value, original value is shown 45. Next, oh God, we got all zeros. What happened? You're wondering? The thing is, without converting, we tried to indicate this integer value as a float. Earlier also, in the previous videos, we have seen I1, when you want to display it as float, it gives junk, right? So you have to convert it. How we have converted this into float and displayed. Let us see what happens. Yes, it is after converting, it is showing its actual value 45, but of course decimal places are shown because we are showing it as a float. 6 decimal places will be shown. That's how. So here, what is happening? With our intervention, we have to declare that we have to convert into a float and use it as a float. That's why, because we are doing it, this type of conversion is called explicit conversion. Clear? Next. We'll do the reverse, float to integer. What happens? We have taken a float f1. Its value is 123.786. I want to display f1 as it is, as a float. No problem. Here, I want to display this f1 as integer. Okay, I am not doing any conversion without converting. F1 as it is. Next, I want to convert this f1 into integer and I want to display it as integer only. Okay, after conversion, I want to display it as integer. Without conversion, I want to display it as integer. Let us see how the output or the display will be. So compile it and execute. The first statement, no problem. As it is, we get it because it's a float. We got 6 decimal places. Next, second one, you observe it. We got a junk. We got junk. That is some ridiculous value because we tried to display a float as integer, which is ridiculous. That's why it has a displayed junk value. Next, we have done the operation, a float to integer. When a float is converted to integer, all the decimal places beyond this decimal place, all these will be truncated and only this integer value is taken. So 123. So it displays as integer, it is displaying 123. That's how we have to convert this one type of data item to another type. Clear? Here, because our role is there in conversion of this data item, this is called explicit conversion. Clear? Next. Explicit conversion. Let us see some example. I have taken, I want to do some division operation, right? Making use of this typecast operator. I have taken an integer integer a 123, and I want to a is displayed as it is, division of a here, a value as integer, no problem, and I want to do a division a by 100, right? The division of this number with 100. I want to divide this a, which is an integer, 123 divided by 100. And I want to indicate the integer value here. What do you think? 123 by 100, what would be the output? We expect 1.23 generally. But here, let us see what happens. And I want to do one more experiment here. I will convert this a into float. A is an integer, but I want to convert this a into float and then divide this by 100 and display it as float. Let us see what happens. Compile and execute. You get the first, the division of 123 divided by 100. We got 1. What happened? This 0.23 has gone. Where? Because we are doing integer division, integers, a division between two integer values. 123 is integer, 100 is an integer. So 123 by 100 integer values. So that 0.23 has gone and is displaying only an integer, right? This integer here, 1. When you convert this into float, 123 divided by 100 is equal to 1.23. So we should get 1.23. Yes, we got it. Because we have declared it as a float, we got 6 decimal places. Okay. Next, it is up to you to show how many decimal places are. So to get the correct answer, you have to make use of this conversion also. Without this sort of conversion, suppose if we try to do this calculation, we get a ridiculous, absurd results. Finally, we get absurd results like this. So 1.23 is the actual value. It is showing only 1. So that's why this type of data conversion is a must. Wherever is required, we have to do it meticulously. Next. So we'll do one more experiment here. Integer a 100, b is 3. Declared C and D as floats. Okay. Now, I want to divide a by b. A is a 100 mean integer. 3 is also integer, 100 by 3. Let us see what happens. I want to display this C value here. Because it is declared as float, I am showing it as float. Okay. Next, I take D. Same A by B, but I want to convert this A into float and B also into float. And then do the division, right? This division operation is done between two float values. Here, two integer values. So D is a float here. Let us see how will be the result. So I want to display D as float. Complete the program, compile and execute. You get the first one as 33.000 because A by B 100 by 3 is a division between two integer values. Even though it is 33.3333, it is truncating that value and taken only that integer value 33. But we have declared, we have tried to display it as float. It is showing the decimal places. That's it. Okay. Now, next, D is equal to actual value beta 33.33 original value has come. Why? Because this operation has taken place between two float values. Float by float. That's why 33.333 actual value has come. Right value has come. So that's why we should be very careful in declaring and converting the these data elements, right? Next. Here, one small experiment done here to understand how this 10 by 3, a division between two values, two integers, of course, here. But A is declared as a float, and I want to indicate this A, even though it is declared as float, I want to display it as integer. What happens? You know that. Clear? So if you try to display a float as a integer, it gives junk. We know that. So there is no need of discussion further here. Next, suppose I did the same thing. A is equal to 10 by 3, no problem. And because it is a float, it has given error when I tried to show it as integer. So because it is a float, I am showing it as a float. So I want to display the value of A as float here. What should be the outcome? Can you guess? You may be thinking that 10 by 3 is equal to 3.3333, something like that. But if you observe the output, you get 3 point all zeros. Why? Because this division has taken place between two integer values. 10 by 3 integer division. So that 0.3333 is truncated and has taken only the integer 3. Because we have declared showing it as a float, this decimal places have come. That's it. Okay, next. I have converted this 10 into 10.0. Nothing, there is no change in the value, but I am treating it as a float. 10.0 divided by 3.0. Let us see what happens. I want to display the value of A. You got the correct answer because the division has taken place between two float values, right? That's why you got the correct value. Next, suppose I have taken 10 by 3. That appears like it is a division between integers, but we have converted this into a float. Even though it is a integer division, 10 by 3, we converted this to float, right? Converted to float. Now, I want to display A. The A value will be good. Original actual value 3.333, because we have converted, even though it is an integer division, converted this to float. That's why we didn't lose any data. Clear? Next. Suppose I have taken A as integer and 10 by 3 I have taken float because we got the correct value when you try to do the division between two floats, right? So A is equal to 10 by 3 float, and A is declared as integer. So I have taken I. You know what happens. What will be the result? Can you guess? The result will be 3. Because what happened? Because we have converted this to float, 10 by 3 gives 3.33333. But when you try to display it as an integer, that 0.333 is truncated and you get the 3 integer value only. That's how you have to be very careful in dealing with the data. Clear? So we have seen the data conversion operations, and when you are performing certain operations, we have to be careful and you have to convert them to the required data type. Otherwise, we get some sort of errors. So to avoid them, use data conversion in a proper way. In the next video, we are going to see arithmetic operators. If you have not subscribed so far, please subscribe to these videos if you like them. Thank you very much.